In this video, I'm going to guide you through determining outputs and the domain from a function equation. I'll let you do the work, but I'll sort of give you the ideas as you go along. So go ahead and copy this down. Assume f of x equals the square root of 4 minus x over x squared minus 25. That's the function we'll be using for all the parts of this video. So part A, determine f of negative 10. Pause and make sure you've got that copied down. So if you're determining f of negative 10, that means that this negative 10 will be the x value or the input to the function. So what I want you to do is to plug that in, and so your next step is going to look like a fraction where negative 10 is substituted in for x. And once you do that, simplify it if you can and see what you get. Pause the video while you work on that. Part B, copy this down, determine f of negative 5, and so same idea, plug negative 5 into the function as your input and simplify again if possible and see what you get. Pause the video while you work on that. Part C, determine f of 0. And this is the same process as parts A and B. Pause while you work this out. Okay, part D, determine f of 3.9, just to see that your inputs do not have to be whole numbers. This time, when you plug it in, I'm not so worried about you simplifying completely, so just see what you get. Pause while you work that out. Part E, determine f of 4. Go ahead and simplify if possible. Part F, determine f of 4.1. Part G, determine f of 5. Part H, determine f of 100. So all of these explore the same concept of using the proper notation and plugging an input into a function to try to calculate an output. Alright, so now what we want to do for part I, let's call it, write the domain of f in interval notation. Go ahead and pause while you write those instructions down. We're still working with the same function we had initially. Now what we're looking for here for domain is x values that you can plug in, inputs that work, basically. Inputs that work, that give real number outputs. So in this particular problem, you've got a couple calculation issues to worry about. You've got a square root, so any x values that you choose can't result in a negative number under the square root. Now that means basically when you look at your number line to kind of keep track of your domain, you're going to cut your number line at a value, and half of the number line, half of those x values on the number line will work when you plug them into the square root, and the other half won't. So the question is, how do you figure out this threshold value here that separates the number line or cuts it in half? Well, the idea is take this, what's under the square root, it's called the radicand, and set it equal to 0 and solve for x. So pause while you do that and cut your number line at that value. Now, that's not the only calculation issue you could run into. You've also got division in this function. So any x value you choose also can't cause problems with the division. So in this case, you're going to go and you're going to find values of x that make this guy equal to 0. So set this x squared minus 25 equal to 0 and solve that equation for x, and then come back and cut your number line again. And what you'll find is you're going to cut to the left of your first threshold and to the right of that threshold at two different values. So those will be the x values that make this denominator equal 0. Pause while you do that. Once you've got that done, you've got to look at each of these numbers where you cut the number line for x, plug them into the entire function and see if you get an output. Okay? If you do, then shade the numbers that work, and if you don't, put open circles around the numbers that don't work. Pause while you do that. Finally, the last thing you'll do is you'll need to check each of the regions between those critical cut points on your number line. So now what I want you to do is check each of the regions on your number line. So pick a number from each region, plug that number into the function for all the x's, and see if you get an output. If you do get an output, a real number output, shade that corresponding region on your number line. If you don't get an output, put an X through that region on your number line. Pause while you do that. Okay, finally, convert your number line chart to interval notation. Remember, use brackets when an endpoint of a shaded region is included, and use parentheses when the endpoint is not included. So pause while you write your interval notation. Okay, now I'm going to give you the correct answers to all of these so you can check your work. And here are the answers to all the parts of the question. Be sure that you pause the video, check your answers, and if they're incorrect, try to figure out why and see if you can fix them. Good luck!